Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is maximum number of points that you can get, and it is going to be a medium level problem. So the problem is very straightforward with the small observation that we have. The problem says that we have been given 3n piles of coins, right? So the number of coins or the number of piles of coins is going to be a multiple of 3. Right, in each step we have to choose any 3 piles, not necessarily consecutive. That means we can choose any of the 3 piles, the order doesn't matter and they don't have to be consecutive. Right, and Alice is going to pick the pile with maximum number of coins, we are going to pick the next maximum, and Bob is going to pick the last pile of coins. Now we have to repeat this step until there are no more pile of coins. So there will be always an integer number of operations, and each of them will get some pile of coin in each operations because the number of piles is 3n. Right. Now we have to determine what is the maximum number of coins that we can have. So let us see this problem with the help of an example. So if I just write this particular example in sorted order, so this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right. So let us just choose, let me have Alice and me and Bob. Right. So these are the 3 players. Alice will always get the pile with maximum number of coins. Now let us just choose 2 piles for these 2 players, any 2 piles. So no matter which pile I choose, Alice will always get the maximum. So let's say I choose this one and this one, right? So Alice will always going to get 8, right? And Bob is, I am always going to get 5, right? That means in any of the cases, no matter how many, like no matter how I choose the piles, Alice is always going to get the maximum pile. That means this pile, the largest pile, will always be reserved for Alice, right? So if this is reserved for Alice, then why not take this particular pile with Alice and choose it for myself, right? So that means since Alice is going to get the maximum pile anyways, I'm just going to take the second best pile, right? So if Alice is choosing 9, I'm going to choose 8. Right, because if I choose any other pile, then in the next step Alice is going to get 8 itself, right? So it's better for me to choose 8. Now since these 2 piles are taken, now we have formed the same problem with this new set of piles. Now the maximum is 7, that means Alice is always going to get 7, so why not take 6 for myself, right? So this way I'm going to always get the second maximum pile. Now what about Bob? For Bob, we know that among 3 piles, he is always going to get the smallest, right? And I don't want to lose these larger piles, right? Whatever I am having from the right, the larger piles, I don't want to lose them. So instead, what I'll do, I'll give Bob piles from the smallest side, right? So for each operation, what you're going to do, our final observation is that for each operation, I'm going to take 2 piles from the back, that is the maximum 2 piles, and 1 pile from the front. So this way Alice is going to get this maximum pile, I'm going to get the second maximum pile, and Bob is always going to get this smaller pile. So why are we giving Bob this smaller pile? So that he doesn't take any of these piles which we could have taken, right? So this is our whole idea. Again, I'm going to choose 2 piles from here, and then 1 pile from here, and then 2 piles from here, and then 1 pile from here. So you see, I'm going to get 8 plus 6 plus 4, 6 plus 4 is 10, and 10 plus 8 is 18, right? So this was our expected answer, 18, right? So you can implement this problem in any way you want. What I have done is I have sorted the piles in reverse order. So what I'll have is I'll have 9, 8, 7, 6, 5, 4, 3, 2 and 1. Now what I do, I'm going to initialize my answer with 0, and I'm just going to traverse the piles array starting from position 1 and incrementing I by 2. Right, so first I am here, then here, and so on. At each step, I am adding piles of I to my answer, and I am removing one element from the back. So basically, this element will be given to Bob, and hence I am removing this particular element, and I am only going till less than piles of size. So you will see what happens in each iteration. First of all, I am here, so I add 8 to my answer, and this will be removed, right, from the whole vector. Then I am here, I add 6 to my answer, and this will be removed from the whole vector. Then I am here, and then I'll add 4 to my answer, and this will be removed from the whole vector. Now when I do I plus 2, it will be out of the size of the vector, hence my for loop will break. So this is how you can solve this problem, and this is my implementation. Obviously you can implement this problem in any other way possible, but the idea will be the same. So this is it for this particular video. I hope that you guys were able to understand the solution and the idea behind this problem. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.